Very good morning, students. Let us see how to implement a full subtractor using De-Multiplexer. The question is implement or design a full subtractor circuit using De-Multiplexer circuit. So first we need to understand what is full subtractor so that we can implement that full subtractor functionality using demultiplexer. You know, full subtractor is used to perform subtraction of three single bit numbers. It means it can subtract x minus y minus z. It can subtract three numbers, a minus b minus c, or x minus y minus z, or l minus m minus s. So its operation is to do subtraction of three single bit numbers so that the input is three numbers, operation is x minus y minus z, outputs for a subtractor is difference and borrow. Okay, difference between x minus y minus z, and if there is a borrow generated, borrow will be the output. So three inputs, two outputs is for full subtractor. Now what is the first step to implement a full subtractor using demultiplexer is write the truth table of full subtractor, whatever be the question it is. If they ask you to implement full adder, you need to write the truth table of full adder. If it is full subtractor, write the truth table of full subtractor. Now, what is the truth table of full subtractor? How many inputs you have? A, B, C, or X, Y, Z. Here I have considered it as A, B, and C. And you have two outputs. One is difference, other one is borrow. One is difference, other one is borrow. You know, there are three inputs. It means 8 combinations: 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1 till 1, 1, 1. Now, how will we write this column? We know 3 inputs means 3 zeros till 3 ones, total 8 combinations. First fill this, then go for difference and borrow. What is the job of full subtractor? A minus B minus C. First it does A minus B. 0 minus 0 is 0. Again it does B minus C. 0 minus 0 is 0. So difference 0, borrow 0. Now come to the next one. 0 minus 0 is 0. Again it does 0 minus 1. I cannot subtract a higher number with a lower number. So I need to take a borrow. So I need to make it as 1. Decimal 0 minus 1 is minus 1. In this case, you need to write plus 1. That's it. Ignore that minus. Go for the next one. 0 minus 1. Again, you know, you cannot subtract a higher number from lower number. So you need to take a borrow. 0 minus 1. You need to take a borrow. So borrow is 1. You know 0 minus 1 is minus 1. Ignore that minus. So it is 1. 1 minus 0 is 1. So similarly to this, 0 minus 1 is 1 with a borrow 1. 1 minus 1 is 0. Fill this whole truth table of full subtractor. After filling the truth table of full subtractor, what is the second step? Represent the output of full subtractor in Minterm's form. So I need to represent the output of full subtractor in Minterm form. So what are the outputs? D and B. So D is the difference, B is the borrow. I need to represent in Minterms. So it is a function of A, B, C. F of A, B, C is equal to, I need to represent in Minterms. So M, sum of products are in which position the difference is high. Can you see it is high in position 1. It is high in position 2. It is high in position 4. It is high in position 7. So what are the Minterms for difference? 1, 2, 4 and 7. 1, 2, 4 and 7 for difference. Now come for borrow. How will I write borrow Minterms? Borrow is equal to, it is a function of what? A, B, C, which is equal to summation of Minterms. Now I need to check what are the positions. Borrow is high. It is high for 1, 2, 3 and 7. So 1, 2, 3 and 7. Have I written the Minterm representation? Now we will see the third step. Third step is design the whole job or functionality of full adder using what? Demultiplexer. So now I need to decide what type of demultiplexer I need to use. 1 by 4 or 1 by 8 or 1 by 16. This is depending upon the number of inputs. Now how many inputs we have in a full adder? Full adder has 3 inputs, A, B and C. So I need to use a demultiplexer which has 3 selection lines. So how many inputs and how many combinations? 3 means 8 combinations. 0 till 7. So I use 1 by 8 demultiplexer, which has how many selection lines? 3 selection lines. So my inputs A, my inputs B and input C acts like a selection lines for my demultiplexer. So choice of demultiplexer depends upon the selection lines. The selection lines depends upon the number of inputs. If inputs are A, B, C, then I have 3 selection lines. If there are 3 selection lines, I will have 1 to 8 demultiplexer. Okay. So you know what is demultiplexer. Job of demultiplexer is to forward that input to any one of the output. If I say 1 is to 8, depending upon the selection line, it will forward the input to 8. But now let us see how to design a full adder using demultiplexer. I have drawn a demultiplexer circuit. My input is always 1. I need to make my input Dn as 1. I know what is my ABC. ABC are my inputs A, B, C, which is connected to the selection lines. How am I going to get my difference and borrow? Difference and borrow is given by minterms D and B. So what are the minterms? 1, 2, 4, 7, 1, 2, 3, 7. Just now we have generated 1, 2, 4, 7, 1, 2, 4, 7, 1, 2, 3 and 7. 1, 2, 3 and 7. These minterms are for difference and borrow. Now let us do for difference. Difference is 1, 2, 4, 7. So take 1, take 2, take 4 and take 7. Connected to a OR gate, you get your difference. Now how do you get 1, 2, 3, 7? Borrow 1, 2, 3, 7. Take your 1, take your 2, take your 3 and take your 7. Alright, you get sum of the minterms. This is your borrow. This is how, without using full adder, I have done the functionality of half adder where my inputs are ABC, where my outputs are difference and borrow. This is done with help of demultiplexer. Thank you.